Hello everyone! In this video I'm going to be showing you creating an ASM disk group using a Dell Powerstore storage array. But first, some boring legal stuff. All copyrights belong to their respective owners. Images and text owned by other copyright holders are used here under the guidelines of the fair use provision of the US copyright law. Said images and text are here only for educational purposes and not for making money. I am not getting paid for doing this. When I am getting paid, though, you should know that I am a principal engineer with Dell Technologies. That said, opinions expressed here are my own and do not necessarily represent Dell Technologies or any of its subsidiaries. Alright, let's get on with it. Okay, so let's go ahead and create a new ASM disk group for our database using this Dell Powerstore all-flash storage array. So first, we are going to create some new volumes. Oracle recommends that we use 4 ASM disks per ASM disk group, so let's go ahead and do that. Using the interface, we're going to click on the storage and then add volumes. And next, we're going to click on the create button. Here we can give our volumes a name. You can pick any name you like, but it is usually best to be somewhat descriptive, especially if other workloads are going to be sharing the same storage array. So I am going to use O2 ASM data, as these are for the ASM disk group data and they will be used by my Oracle 2 VM. Next up, let's give it a description. And now we can specify how many volumes. In this case, we are adding 4. And let's select a size for our volumes. Note, if you are still using Oracle 11G, it's long past time to upgrade. No, seriously, if you are using Oracle 11G or if your ASM disk group compatibility is set to less than 12C and it still defaults to 10G, so watch out, the largest volume that you can select is 2 terabytes, and that's an ASM disk limitation. But we're fine with just 1 terabyte. At this point in time, we are not going to assign a volume group or a protection policy. We'll come back to those in a later video. For performance, we can choose between low, medium, and high. This is simply a quality of service marker. High performance volumes will be serviced before medium, which in turn are serviced before low. All volumes, in fact, will use the same erasure coding, which is based on how many simultaneous drive failures your Powerstore is set up to handle. And that is decided when the system is first configured. There is nothing else we have to do here right now. Now we can just click Finish right here, or we can click Next to map our volumes to a host. For now though, we are just going to click Finish. And we get a little dialog to tell us that our volumes are created. Okay, so here they are, our 4 new volumes. Next, we need to map them to the host where we are actually going to use them. This environment is virtualized, but it is basically the same for bare metal servers. Multi-select the new volumes, and then select Provision, and then select Map. Our Oracle VM is on Cluster 1, and we are using Fiber Channel SCSI. Click Finish. Again, let's check the dialog, and once it is finished, we can move to vSphere. In vSphere, we need to rescan the HBA adapters of the various servers that are in our ESX cluster. So we click on Storage, Rescan Storage, and then we're going to deselect the Scan for New VMFS Volumes as we don't need that option, and then click OK. Wait a second, and the jobs will show up as completed in our recent task, one for each of the servers in our cluster. Next, we can go to our VM and add our new storage. So we're going to right-click and say Edit Settings. And then we're going to be able to add a new device, a new RDM. When we show our target LUNs, we can see that there are 4 new volumes at 1 terabyte each. So those are obviously the ones that we just added. But we can double check that by opening out the path ID, which will then show us the volume WWN, or worldwide name. We can then compare that to the Powerstore. If we select the Details button, we can then add the WWN to our display, and then resize the column so we can actually read it. And there you can see that we have 4 new volumes and the WWNs are shown. So 6C4FF if we go back into the vSphere, we can find that same volume right there. Click OK. And then we're going to add the other 3 new volumes. Now, we're using RDMs for this example. You could, of course, create new volumes and use them as VMFS and VMDK files, or in fact vvols. And there are pros and cons to each approach, but the RDM option allows us to use all the features and functionality of the Powerstore. Once we've added all 4 volumes, we can then decide which PowerVirtual SCSI adapter each one will sit on. It's good practice to spread them across the available adapters. So we'll have one on adapter 3, we'll have one on adapter 2, one on adapter 1, and the last one can stay on adapter 0. And the VM will reconfigure. And now when we go to Linux in our guest, we should be able to see our new volumes. So we've logged into our guest VM, and now we're going to SU into the root user and take a look at the block devices that we've just added. So to do that, we use the ls SCSI command with the WWN switch, and that will show us the block devices and the WWN IDs. And you can see that they match the ones that we added from the Powerstore. We can also use the lsblk command to take a look at the sizes of those devices. And if we combine the two together, we can actually get Linux to tell us both the WWN IDs and the sizes in the same command. And I'll post a link to that in the description. So next we have a choice to make. We need to create some device ownership. Right now they're owned by root. You can use ASMlib, you can use ASM filter drivers, or you can use Udev rules, which are built into Linux. So we're going to use this script here to create ourselves some Udev rules for those 4 devices. They will be owned by the grid user under the group ASM admin, and we're going to create our devices with the name data for the data ASM disk group, and we'll feed in those 4 devices that we just saw: SDB, SDC, SDD, and SDE. There they are, and it found all 4. So we're going to put those into a Udev rules file, which is in the etc Udev rules directory. And then when we've created that file, we can go ahead and restart the Udev rule processor, at which point our 4 new devices should show up in the /dev/Oracle ASM directory owned by Grid, with the ASM admin having group rights to those devices. And there are our 4 new devices. So next we need to go to the grid user and create our ASM disk group. Next we're going to log into the grid user and source the ASM environment. Now we can use the ASM Configuration Assistant, or ASMCA, to go ahead and create our new ASM disk group. So click on the disk group button, and that will take us to a screen that allows us to create the new disk group. So click on the Create button at the bottom. And here we can specify our new disk group. So we're going to give it a name, and we're going to call it Data. The redundancy will be set to external. That means let the Powerstore take care of data redundancy. We don't need ASM to do it for us. The allocation unit size we'll leave at 4 megabytes. That's a pretty good size, a one-size-fits-all, and is suitable for most workloads. For disks, we'll select all 4 of the new disks that we've added, and then we'll click OK to go ahead and create our new disk group. And that's it done, a new data ASM disk group, 4 terabytes in size, comprised of 4 1 terabyte volumes from our Dell Powerstore storage array. Click Exit and go back to Linux. Alright everyone, that's all we've got time for today. I hope you found that useful, and if you did, maybe click like, maybe even subscribe to the channel, and check out my blog at thegruffdba.wordpress.com. Alright, thanks everyone.